In this demo, we are going to demonstrate orchestration and control loop automation of Open5GS and UE ransom using AMCOP. This is the orchestration flow in which AMCOP in management cluster deploys Open5GS in cluster 1 and uransom in cluster 2 and starts monitoring the SLA once UE connects to internet. This is the AMCOP UI, where we have onboard cluster 1 for Open5GS and cluster 2 for UE ransom. We have created Open5GS and uransom service instances and instantiated to deploy them in their target clusters. We can see Open5GS and uransom is deployed and running successfully in their respective clusters. And UE is able to ping google.com successfully, with latency of around 163 milliseconds. This is the control loop flow where the control loop application of AMCOP monitors the SLA. If the SLA is not met, it takes corrective action by deploying one more instance of UPF and uransom in the enterprise edge cluster. Earlier, as UE was able to ping google.com, the control loop application of AMCOP has started monitoring the SLA. We can see that the SLA defined for uplink and downlink speed is 20 milliseconds, however, the evaluated SLA is not 20 milliseconds. So, the control loop application shows warning count up to 3 and is taking corrective action to meet the SLA. It is deploying one more instance of UPF, uransom, as corrective action in the enterprise edge cluster to minimize latency. Now that the corrective action has successfully occurred, we can observe one more instance of Open5GS UPF and uransom in the AMCOP UI. Additionally, they have been deployed and are running successfully in the enterprise edge cluster. Now since the UE, UPF are in the same enterprise edge cluster, latency will be minimal. Before the corrective action, latency was around 163 milliseconds. But after corrective action, latency is just around 14 milliseconds as UE and UPF are in the same enterprise edge cluster.